Hi, everybody. So let's talk about this last section. So this last section is the quote-unquote proof section, okay? So the idea here, just like the very last thing we talked about in the unit, is just to look at these triangles and ask ourselves one extremely important question: can I prove these to be similar? Now, the catch here is when we talk about them being similar, we're not going to use the full definition of all corresponding angles to be congruent and all corresponding sides to be proportional. And so we're going to be using the shortcuts. And just for the record, because of the link to congruency, we can either show just two angles are congruent, we can show all the sides are proportional, because remember, that's a big change here. We got to show proportionality, which is no surprise. We've been doing that all review. Or side angle side, where we have two proportional sides and one congruent angle in the middle. Okay, so that has to be our first thought, like which of the shortcuts could even fit the triangle, right? We should provide some evidence to show the shortcut was valid, and that just might be a short list that's going to look very suspiciously like a proof. And then we're going to write a triangle similarity statement, just like triangle blank 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 is similar to triangle blank blank blank, right? And so that's going to be a kind of a three-part approach for these next 18 problems or so, right? But it should go fairly fast. Now, we should be aware that there might be some cases where we can't prove it. And so the way that's going to look is either the sides will not be proportional, or we simply don't have enough angles to make our angle-angle similarity statement, or similarity shortcut idea. All right, so let's jump in. So first things first, we have triangle TNS and triangle PRI, and we want to show they're similar. So in terms of the possible shortcuts, I don't hardly have any information on this triangle at all, but what I do have are angles. I can see one angle here matching the angle here, and then I have a double marked angle matching a double marked angle. And so like the beautiful part about this shortcut is that's all we need. If we just have two angles that we can show to be congruent, I know for sure these triangles are similar. And then the power in that is once they're similar, I know all the sides behave proportionally and the remaining angle is congruent. So I believe it's going to work by angle, but we should provide some evidence, just a quick list. And so like the first angle that we can prove to be congruent is angle S, congruent to angle R. Okay? And this was just given to us. Sometimes we're given numbers, but this is just marked to be congruent, and so we can just say that. The second angle, angle T, or the angle at T to be more accurate, is congruent to the angle at P. This one is also just given to us. It was pre-marked on the diagram, and so we don't have to do any kind of special work. We just have to identify the two angles. Okay? All right, here we go. I'm going to slowly scroll. Oh, it worked, okay. So once I meet angle, I can immediately combine this information and claim the triangles are indeed similar. And so I have to be careful in my order, TRS, or TNS, whoops. Okay, remember the similarity symbols at one tilde or squiggle. So TNS, let's be really careful. So we went from the green angle to the no angle to the blue. Has to be PIR. Okay, PIR, there we go. By angle similarity. Okay, and so that the thing I just circled AA, like that's like the big idea, right? So the shortcut we're using is angle. I've shown the two angles I know to be congruent. I've written a similarity statement. Basically, I wrote a proof. But these two triangles are definitely going to be similar. Let's start with angle 2. Well, I have no angles at all, but luckily I have all the side lengths, right? And so the only possible shortcut is going to be side, side, side. All right, so side, side, side. Now remember, the key difference here is I have to show the sides are proportional, not congruent, but I still have to find the ones that actually match. Now, I don't have any angle information, which is usually the way that I try to orient my triangles, but I could use the Goldilocks principle. Those of you guys not in my class, you may not have talked about the Goldilocks principle, but what this means is if I take the shortest side, of one triangle, which is 3, it can only scale to the shortest side of the other triangle. And so even though like it's hard to see which part corresponds to what part, if there is a correspondence, if there is similarity, small has to be small. Okay, so 3 is the smallest side of my small triangle, 9 is the smallest side of my large triangle, ergo NS has to correspond to RI. Okay, now these have values, NS is 3, RI is 9, and so I have a 0.3 repeating ratio, a 0.3 repeating ratio, at least for my blue parts. To be side, 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 all the sides have to be corresponding and proportional. So 4, the second largest side, has to correspond to 12. In other words, Tn, my small side triangle, has to correspond to Pi. Okay? In other words, 4 has to go to 12. Well, 4 divided by 12 is also 0.3 repeating. So I do have two ratios the same, but I can't call it proportional until all three are. And so my last one, Ts, has to correspond to the largest side on the other triangle, PR. There we go. In other words, 5 has to be in a ratio with 15. 5 divided by 15 is also 0.3 repeating. And so here's what's important. So all three sides are the same. All three side ratios are the same. And so that means the fractional ratios are the same and the side ratios are the same. So what I can conclude is triangle PRI. Okay, so look at the order PRI. So I went along the red side, then along the blue side. Has to be similar to TSN. So along the red side, up the blue side. Okay, and this is going to be by side, side, side. Okay, and so like the recognition of which shortcut can be possible sets off our work. We were only given side lengths in this example, and therefore we're going to have to use side lengths to prove the triangle similar. They have to be proportional, which means all corresponding side lengths have to have the same ratio. And so I set the ratio order, I substitute the side values, divided those numbers to get a decimalized ratio. I showed that all 0.3 are repeating, therefore the triangles are similar by side, side, side. And so what that is a further important implication is now we know all the angles have to be congruent too. All right, very slowly scrolling. All right, there we go. One click up, there we go. All right, so next set of sides, or next set of triangles, excuse me. Well, I don't have all the sides, and I don't have all the angles, but what I do have is one angle, okay, that matches the angle up here. Then I have a side length corresponding to another side length, and I have a side length corresponding to another side length. And so I have an angle in between two side lengths, and so the only one that could possibly match at this point would have to be side angle side. Now I don't know if it matches at this point, but if I have a shot of showing similarity, this is going to be the only way I could possibly show it. Okay, let's do the angle first, that's easy. Angle I is congruent to angle N, because that's what was just given to us, right? Like it was marked on the diagram. Okay, the tougher part's going to be the side lengths. So we have to set a ratio order. Let's go small over large. So NS is to RI. So small triangle green, big triangle green. But we have values, and so that's going to be 4 over 6. 4 over 6 is the same as 2/3. 2/3 is the same as 0.3 repeating, or 0.6 repeating. And so that's going to be that ratio. Let's see if the blue one matches, because the only chance that these are going to have to be similar is that we have to have the same the same ratio for the other set of sides. And so we'll have to go small triangle TN over large triangle PI with values that's 7 over 10.5. And I can't do that one in my head. Let me grab my calculator. I'm sure it's here somewhere. Here it is. So 7 divided by 10.5 is going to be also, look at that, 0.6 repeating. Okay, so I have two side lengths that are proportional because they clearly have the same ratio, 0.6 repeating. I have the angle in between them that's going to be congruent. And so it looks like these triangles are going to be similar. So let's see, triangle TNS. So start with T, go up the blue side and down the green side is going to be similar to triangle PIR. Okay, and in this case, it's by side angle side. Okay, where the sides are proportional and the angle between them is going to be congruent. All right, next example. Evaluate the given information. Well, I have no angles, so it can't be side angle side, and it can't be angle angle, but I have all the sides, and so that gives me a chance at side 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 if I can show that everything is proportional, which means I'm writing ratios, which means I'm finding corresponding sides. Here I have 1147, right? That's going to be ED. That's the largest side of that triangle. And so it has to correspond to the largest side of this triangle. That's going to be TU. Okay, and it looks like I put big triangle over small triangle. So when I substitute values, that'll be 1147 divided by 527. Definitely can't do that in my head. 1147 divided by 527. That gives me, ooh, that's a weird one, 2.176 approximately, right? So it's about that number. There's some decimals I have to round off. All right, so here we have the small side. Oh, 666. Oh man. Okay, so we went small triangle over. Let's see. Oh, sorry. We have large triangle over small triangle, and so we have to do FD this time. Okay, the smallest side in this triangle will be 306, so that's going to be SU. Okay, so 666 over US. No. 306, we're substituting numbers. All right, so 666 divided by 306, we got, oh, look at this. We got 2.176. So we got 2 to match. Okay, so let's see if that third one matches. All right, so large triangle over small triangle. So EF is the same as TU, or in other words, 777 or 527. Okay, and I got 1.474 approximately. Let me double check my work. 777 divided by 527. So medium side. Oh, that's not right. Oh, hold on. TS. This should be TS. Oh man. Some of you guys are probably like, wait a minute, what's he doing? TS. There we go. And so that should be 358. That's going to change my ratio. Okay, so 777 divided by 358 should be 2.170. 2.170. All right. So again, let me just double check here. So we got largest side 1147 over largest side 527. We got smallest side 666 over smallest side 306. We have largest side 777, medium size, excuse me, middle side 777 over middle side 358. 777 divided by 358. It's 2.170. Okay, so the reason I was double checking is because these numbers are awfully close, aren't they? So we have, got a different color here. So we have 2.176, which is equal to 2.176, but that is not equal to 2.170, right? It's close, but it's not exact. And so here's my conclusion. The triangles are, S, are not similar. Okay, and so the reason being is because we have no angle information, and so all we have to work with are the side ratios, and clearly the ratios are not all the same. If the ratios aren't the same, that means we don't have equal fractional ratios, which means we don't have equal side ratios. Ergo, these triangles are not proportional. If they're not proportional, then we cannot say they're going to be similar based on side, side, side. Okay, and that's what we're talking about when we said there's going to be some non-examples. That's this is an example. This is one of the non-examples. Okay, let's move down to the next page. I think there's 3 total pages here, and so we do have to be careful for the non-examples. All right. So same deal. First thing we should evaluate is can we even, can we prove this by any of the shortcuts? Well, no angle information at all, but we do have side information, and so side, side, side is definitely in play. Let's see if it all works out. This one's even color-coded for us. Look at this. They're making life real easy. So we have 6 over 8. So red is to red. Okay, so 12 is to 16. Small triangle over large triangle. And then we have 9 over 10. Okay? Let's just check ratios. So 6 divided by 8 gives us 0.75. Okay? 12 divided by 16 gives us 0.75. This is looking good. The two ratios are the same. Okay, and then 9 over 10. 9 over 10 is 0.9. So we have two sides, or two ratios excuse me. Okay, we have two ratio values that are clearly the same, 0.75 and 0.75, but that is not equal to the final ratio value that is 0.9, which means these two ratios are the same, this ratio is not the same, and for side-side-side similarity to work, all the sides have to have the same ratio value. That makes them proportional. And so the triangles, again, okay, and so that's a conclusion you could reasonably reach. Like if it doesn't meet the shortcut, man, it just doesn't meet the shortcut. All right, so here we have two sets of sides. So we're definitely not going to use angle, but we don't have the third set of sides, so we're not going to use side. But we do know a bit of geometry. We can add one piece of information, and it's no surprise we have this crossing part, and so we do have these two angles that are going to be congruent by vertical. They're flanked by side lengths, and so I think we have a shot at proving side angle side, if everything works out. Okay, we know angle 1 is going to be congruent to angle 2. That's easy. That's by vertical angles. There we go. Let's check out these side lengths. So we have BC. That's the smallest side in the smallest triangle. And so it could only correspond to 15, the smaller of the two side lengths. And so we have CE is to BC. So I chose large triangle over small triangle just because I wanted to. And so substituting in numbers, we have 15 is to 9. And so 15 divided by 9 is going to be 1.6 repeating. So that's going to be our scale factor or decimalized ratio. All right, so we have to follow suit. And so we have these two sides are definitely going to be corresponding, but we're going to take large over small. So CD over AC. Let's substitute in some values. That's going to be 30 over 18. So 30 divided by 18, 1.6 repeating. All right, so we're good because we have two sets of sides that have the same ratio, the same scale factor, 1.6. We have an angle in between them that we know for sure is going to be congruent, even if we don't know the value. But we did meet side, angle, side. Therefore, triangle ABC has to be similar. Let's see, ABC starts at red corner, goes, okay, so it has to be DEC, so deck. There we go. And this is going to be by side, angle, side. Okay. All right, moving on. So no side information, so side is out. Side angle, side is out. But we do have at least two angles, so angle is definitely in play if I can show all the values. All right, so we have E and we have L. So angle E is congruent to angle L. Is given to us, but we know 102 degrees by rule is equal to 102 degrees. Oh man, come on board. We're almost done. We're almost done. Stop messing around. All right, so equal to 102 degrees. We can also just say it's given. Either one I think is equally good because we're not, like I said, we're not really proving here. We run into a problem though because like 48 and 30 are clearly not the same angle. But we don't really know what corresponds to what because we have no side information. So it's probably pertinent that we get as much angle information as we can. Now we're not given anything else, but we know something about triangles. All the angles of a triangle add to 180 degrees. That's by the triangle sum theorem. And so I know that this angle here must be 48 degrees. And look at that, 48, and we have a 48 in the other one. We can triangle sum theorem this side as well, but we can determine if it's going to be 30 degrees. But it does look like we do have another matching angle. We have angle G, congruent to angle N. Okay, because 48 is the same as 48. Okay, we know that by the triangle sum theorem. There we go, triangle sum theorem. So we met two angles, even though we had to work a little bit harder for them. We can definitely conclude that triangle GEF is similar, GEF goes from, let's see, green angle to red angle to no angle, so this one has to be NLM. And this is going to be by angle. Okay, and so we do have to sometimes use our geometric knowledge to find extra parts. That's just an example of how that's going to go. Well, all side information, so you know where this is going. We got to test out to see if it's side. We should be cautious because we've had some non-examples, right? Some examples that didn't work out so well. Corresponding parts, well, no angles can orient us. We have no statements, so we got to go Goldilocks principle. So if I go AC, okay, AC is the smallest side length on the left-hand triangle. The smallest side length here is 10, so that's going to be DE. And so I'm looking at 14 over 10, or 1.4. Let me confirm that, because you never know, I might be doing some arithmetic wrong. Now it's 1.4, we're good. Okay, so 28, largest side, CB, has to correspond to largest side, FD. Okay, so 28 is to 20. So 28 divided by 20. That's also 1.4. Oh man, this is looking good. All right, last sides, AB, medium side, big triangle. FE, medium side, small triangle. So 21 and 15. 21 divided by 15, is it 1.4? Oh yeah, it is, look at that. Okay, so we know that the decimalized ratios are the same value, which means the fractional ones are the same value, which means the side length ratios are the same value. And so there's only one conclusion we can reach, is that a triangle is similar to the triangle. But of course I can't see everything at once, so let me do some scrolling. So a triangle, oh man, ABC, let's see, ABC, should be FED, ABC and FED. All right, so A, B, C, F, E, D, D, there we go, by side, 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 triangle similarity theorem where the sides are all shown to be proportional. All right, I think we have one more page, I can't remember. Oh, we do, okay, good. All right, so hopefully this is becoming adequately repetitive. That means like you're understanding and socking into your brain. We don't have all the angles, we don't have all the sides, but we have a mixture, right? So we have a side that corresponds to a side, because they're both the smallest sides. We have another side, 28, that correspond to NQ, because they're both the largest. And lucky for us, we have an angle that goes right in between them that's marked to be right angles, and of course those are going to be congruent. And so that sets us up for side, angle, side similarity. Okay? You know I'm going to do that angle first because that's the easiest one. Angle R is congruent to angle N because they're both right. There we go. And so notice I'm being a little bit looser on my justifications. I'm not worrying about writing a real proof here. I'm just trying to convey some ideas. Okay, so for this side we have SR, large triangle, over PN, small triangle, both the left-hand sides. And so 24 is to 18. I feel like I just did this one. 24 and 18. Is that 1.4? Let's find out. 24 and 18. 1.3 repeating. I was close. The 1.3 repeating. Okay, so of course we're going to check that against the other side ratio. We went large over small, so this has got to be RT. Oh, come on. over NQ, or 28 over 21. 28 divided by 21. If it's 1.3, we're in business. Otherwise, it's not going to be similar. Oh, but look at that. It's going to be 1.3. And so we met side angle side, 2 proportional side length with the angle in between. So let's write a triangle similarity statement. TRS is similar to Q and P by side angle side similarity. And as you guys can see, my board and my computer are struggling, but we're going to get through this. All right, no side information, but we have a couple angles. We know, we can tell visually that all none of the angles add up, or line up, excuse me, but we can use triangle sum theorem to determine this last angle is 105 degrees. Okay, and that gives us some matching pairs, because I see 21 matches 21. Angle A congruent to angle F, because 21 degrees is the same as 21 degrees. Okay, which has always been given to us. That was just there, right? And then for our second angle, we have the 105 and the 105. So angle 2, the angle at B congruent to the angle at D, because 105 is equal to 105. Okay, and that was a triangle sum theorem. Boom. Okay, so I've met angle, so we can just write our triangle similarity statement. So let's keep it simple, because my pen, my board, everything's breaking down. ABC, so I go from green angle to purple angle up. And so, I'm sorry, red angle to purple angle up, so this has got to be F, D, E, by angle, angle. All right, 2 more, guys, and we've made it. All right, oh man, we got overlapping triangles. Well, we've kind of seen how to handle this kind of problem. We're going to redraw them. So I have 4 and 5. Okay, so this isn't 12. Remember, it's going to be the entire side length. 12 and 4, that makes 16. 5 and 15, that makes 20. Now, I don't have the third side length, so SAS is out. I also don't have any angles, so angle is out. My only hope, I think, is to actually use side angle side. And so if we go back to original drawing, the thing that we have to pay attention to is that they are overlapping. And so this angle up here at S, I'm trying to highlight in blue right now. Okay, so this angle up here is actually the same in both. And so that blue angle appears here, and that blue angle appears here. They're just overlapping. And so it looks like we are set up for side angle side because we have 2 side lengths with an angle in between them. Now, this isn't guaranteed it's going to work, but that's the only chance we have to prove these are similar. Let's do the angle first. So angle S, congruent to angle S. Okay, now they're overlapping, they're shared in both triangles. That's actually the reflexive property. Okay, so now let's talk about side lengths. All right, so I'm using my diagram in the bottom left where I kind of separated those triangles, right? So we have 4, which is the left-hand side of the small triangle, is to 16, which is the left-hand side of the right triangle. 4 over 16 gives us a 0.25, or 1/4 scale factor. Okay, so we can go 5, right-hand side of the small triangle is to 20. Well, 5 divided by 20, 5 goes into 20 exactly 4 times. That's going to be 0.25. For that scale factor. So we have 2 matching scale factors. We have an angle that's congruent in between. So we've met SAS. Let's talk about the triangles. Let's go SPQ. Okay. Similar to triangle. I'm using my original diagram, top, left, right. And so that's going to be SRT. Okay, so by SAS, similarity. Two proportional side lengths with the angle in between. All right, one last one. Oh man, they're trying to trick us with this one again. Come on, we've seen this too many times to be tricked. So on the big triangle, I have a right angle, that's 90, I have 64 degrees. And so I take that away from 180. Okay, I have this guy to be 26 degrees, which look at that, I have two 26-degree angles. And so it looks like this is going to work out to be good old angle, right? So angle G congruent to angle D because it's given. Well, they're both right. We can say it kind of a lot of different ways. Uh-oh, don't do that. Don't do that. What are you doing? Here we go. There we go. Oh man, this is struggling. So we have angle C and we have angle K. So for our second angle, angle C congruent to angle K. Just imagine my board wasn't messing up this much. This video would be like 30 minutes shorter. All right, so we know 26 degrees is of course the same as 26 degrees. We figured that out by using the triangle sum theorem again. That's like the main thing we use, I think. Come back, oh no! What the? All right, no one move. All right, so for one last time, let's name the triangles. So we have CED. Okay, and I'm just kind of randomly picking that first one if you were wondering. So CED, so red to nothing to purple, so that's got to be KHG. And that's going to be, in this case, by, what was it, angle A. There it is. Okay, so what's the takeaway from these problems? Well, if you can't prove using all corresponding angles are congruent and all corresponding sides are congruent, then the next best thing is a shortcut. And we have those borrowed from similarity, right? Or sorry, borrowed from congruency. So side, angle is kind of the new one-ish, depending on kind of how you absorb that information. And of course, side. The big difference being that you have to actually show sides in any case are proportional, not congruent. And so that means we got to match up corresponding sides, which seems to be like a common theme here, right? And we got to check those ratios. Now, it is completely possible that those ratios don't match. And so here's an example where side was the only thing we could have used, but the ratios aren't the same. They're off by 600ths, which isn't a lot, but that makes them different. Ergo, they're not actually going to be similar. But in the case that they are going to be similar, means that all the side lengths are proportional, or all the angles, or sorry, two of the angles are going to be congruent, or you have two proportional side lengths, trapping an angle in between. I have no idea why it's doing that, guys. I wish I did. But thank you for sticking with me. That was a particularly long video, but it's probably actually a very important one, probably maybe the most important one, because proofs do comprise like, about 26.7% of your test, which is a pretty big chunk. All right, guys, so that's the final video. If you have done all the problems with me, if you've gone through this whole review, you're set up for success. Like, there's nothing else we can do to make you more prepared for this test than this. So thank you for watching. Thank you for working and sticking with us. Have a wonderful day. Good luck on your test.